Picture this. It's 1956, and some Swedish engineer walks into a Detroit auto show carrying photographs of a car that looks like someone sat on a Ford and forgot to unsit on it, claiming it'll last 400,000 miles with just 60 horsepower, beam axles, and a 3-speed transmission. Detroit engineers literally laughed in his face because this thing had technology that was already outdated when Eisenhower was elected. Then one of them decided to actually test the claim, and what happened next would haunt American automakers for the next 30 years. Setting the scene, post-war Sweden. The year is 1944. Sweden is one of the few countries in Europe that hasn't been bombed into rubble. They're neutral, sure, but they're also completely cut off from the rest of the automotive world. No American cars, no British imports, no German anything because, well, Germany's a bit busy at the moment trying not to lose a war. Volvo, a company that had been building cars since 1927, was stuck in a weird position. They'd been making heavy, expensive cars that were basically Swedish copies of American designs. Big, slow, thirsty, and only affordable to wealthy Swedes, which in post-war Sweden meant almost nobody. The company was literally on the verge of bankruptcy. The Swedish government came to Volvo with a simple message: build a car that ordinary Swedes can afford, or we're nationalizing your company and turning it into a tractor factory. Not a suggestion, a threat. Volvo's lead engineer, a guy named Helmer Pettersson, was given an impossible task: design a small, affordable car that could survive Swedish winters, terrible Swedish roads, and Swedish driving habits. Oh, and do it with basically no budget, no new tooling, and no access to modern technology because everything was either embargoed or reserved for the war effort. Pettersson looked at the American cars everyone was copying, the big chrome-covered land yachts, and realized something fundamental. Those cars were built for American roads, smooth highways, gas stations every 10 miles, mechanics in every town, mild weather. Sweden had none of that. Sweden had dirt roads that turned into ice rinks for 6 months a year, gas stations separated by 100 kilometers of nothing, mechanics who might see you in 3 weeks if you were lucky. What Sweden needed wasn't a smaller American car. It needed something completely different, something that could take a beating and keep going, something simple enough that a farmer could fix it with basic tools, something efficient enough to run on Sweden's expensive, rationed fuel. The PV444 project started in 1944. The name stood for Person van, 4 cylinders, 4 to 4 for 1944. Creative naming, right? The first prototype was built in secrecy, hidden from both the Swedish government and Volvo's own board of directors, who would have killed the project instantly if they'd known about it. The problem Detroit ignored. Here's what Detroit was building in the mid-1950s. Cars that were 17 feet long, V8 engines making 200-plus horsepower, 3-speed automatics, power everything, chrome that could blind you from orbit. These were amazing machines if you lived in Southern California and drove on perfectly paved roads to your air-conditioned office. But Detroit had a dirty little secret. Their cars were falling apart. Not immediately, not obviously, but by 50,000 miles, they were developing rattles. By 75,000 miles, engines were burning oil. By 100,000 miles, they were basically scrap. This was considered normal, expected even. The automotive industry in America ran on planned obsolescence. Why build a car that lasts 20 years when you can build one that needs replacing in 5? Keep people buying new cars. Keep the factories running. Keep the economy growing. It was brilliant business, terrible engineering. Consumer Reports started tracking this in the early 50s. They found that the average American car in 1956 had a useful life of about 80,000 miles before major repairs exceeded the car's value. Engines wore out, transmissions failed, bodies rusted, suspension components broke. It was just accepted as the cost of car ownership. European cars weren't much better. British cars leaked oil like it was their job. Italian cars rusted if you looked at them wrong. French cars had electrical systems designed by people who apparently hated electricity. German cars were well built but expensive, and parts were impossible to get in most of the world. There was this massive gap in the market. People wanted cars that would last, cars they could depend on, cars that wouldn't bankrupt them in repair costs. But nobody was building them because nobody thought it was possible to build an affordable car that was also durable. The engineering challenge was real. To make a car durable, you needed heavier components. Heavier components meant more weight. More weight meant bigger engines. Bigger engines meant higher costs and worse fuel economy. It was a spiral that always ended at expensive, heavy, thirsty cars that only wealthy people could afford. Detroit's solution was to just accept the trade-off. Build them cheap, sell them cheap, let them wear out, sell another one. The British tried to build them light and nimble, but they sacrificed durability. The Germans built them durable, but they were expensive. Everyone had picked their compromise. Except Volvo. Volvo was about to prove that the whole premise was wrong. Enter the PV444. Specs that look pathetic. Let's talk about what the 1956 Volvo PV444 actually was, because on paper, it's hilarious. The engine was a 1.4-liter inline-4, making, wait for it, 40 horsepower in the original version. By 56, they'd gotten it all the way up to 60 horsepower. 60. My grandmother's sewing machine makes more power. Actually, that's not fair. My grandmother's sewing machine probably makes about the same power. The transmission was a 3-speed manual. 3 speeds. In 1956, when most American cars had 3-speed automatics or 4-speed manuals. The gear ratios were so tall that first gear was basically what second gear was in a normal car. You started in second gear most of the time, unless you were on a hill. The suspension was beam axles front and rear. Not independent front suspension like modern cars were starting to use. Not even a sophisticated solid axle like trucks had, just beams. The front axle was mounted on leaf springs. Leaf springs, technology from covered wagons. The rear had coil springs, which was almost modern, but still connected to a solid axle. The brakes were drums all around. Tiny drums. 9-inch fronts, 8-inch rears. No power assist, no dual circuit, just a single hydraulic line to all 4 wheels and hope for the best. The brake pedal required approximately the same force as a leg press at the gym. The body was made of steel, but thin steel. The car weighed 2,100 pounds, which sounds light until you realize it was the same weight as a Volkswagen Beetle while being significantly larger. They'd shaved weight everywhere possible, which should have meant the car would dissolve in the first rain. The interior was Spartan, vinyl seats, a dashboard that was literally just a painted metal panel with some gauges stuck in it. No radio as standard. No heater as standard in early models, though they added that because, Sweden. The luxury model, and I use that term loosely, had rubber floor mats instead of bare metal floors. That was the upgrade. Top speed was 85 miles per hour. Maybe downhill, with a tailwind and someone pushing. 0 to 60 took somewhere around 20 seconds, though nobody bothered timing it because why would you? The speedometer only went to 90 anyway. The styling was, well, it looked like someone had taken a Ford from 1940 and compressed it by 20%. Round fenders, running boards on early models, a grille that looked vaguely European but mostly just confused. It wasn't ugly, exactly. It was just aggressively boring, like a car designed by an accountant who'd been told to make it look like a car. The price in the US market when it finally arrived in '56 was about $2,000. That's $14,000 in today's money. Not cheap. For comparison, a Chevrolet Bel Air cost about $2,200 but came with a V8 and actual features. On paper, there was absolutely no reason to buy this car. None. It was slow, basic, underpowered, and not even that cheap. Car and Driver called it transportation in its most Scandinavian form, which wasn't a compliment. Motor Trend didn't even bother reviewing it. Road and Track mentioned it existed and moved on. But here's where it gets interesting. The engineering nobody saw coming. What nobody understood about the PV444 was that every single decision Helmer Pedersen made was about durability. Not performance, not comfort, not style. Just making this thing survive longer than anything else on the road. The engine was the key to everything. That pathetic 40 horsepower motor, later 60 horsepower, was built to tolerances that would make a Swiss watchmaker proud. The cylinder block was cast iron, but not just any cast iron. Volvo developed a special alloy with higher nickel content that resisted wear better than standard automotive iron. The pistons were forged aluminum instead of cast. More expensive, but they didn't crack under thermal stress. The connecting rods were I-beam forged steel, individually balanced to within 2 grams. The crankshaft was forged, not cast, and hardened through a special heat treatment process that Volvo developed in-house. The bearings were oversized, way oversized. The main bearings were designed to handle double the stress the engine would ever produce. This meant they wore incredibly slowly. Oil pressure was high, 25 psi at idle, 50 psi at speed, forcing lubrication into every clearance. The valves were larger than necessary for the power output. This meant they ran cooler and lasted longer. The valve springs were chrome silicon, the same material used in racing engines, but derated to run at lower stress. They could cycle millions of times without weakening. The oil filter was huge, comically huge. It held nearly as much oil as the engine itself. The oil capacity was 5 quarts in an engine that should have needed 3. This meant longer oil change intervals and better filtration. The oil passages were over-engineered, with larger diameters than necessary to ensure flow even as they accumulated deposits. The cooling system was similarly overbuilt. The radiator had 30% more capacity than the engine needed. The water pump was a truck component, massively overspecified for the application. The thermostat was a simple mechanical device with one moving part, nearly impossible to fail. The transmission was agricultural in its simplicity. 3 gears, each one made of case-hardened steel thick enough to handle 3 times the engine's torque. The synchronizers were brass, soft enough to wear instead of the gears themselves, and designed to be replaceable without splitting the case. The shifter linkage was all metal rods, no cables to stretch or break. Those beam axles everyone laughed at? They were brilliant for durability. No ball joints to wear out, no control arms to crack, no rubber bushings to deteriorate, just solid steel beams that would outlast the car. The leaf springs in front were 6-leaf units that distributed stress evenly, nearly impossible to break. The rear coil springs were wound from spring steel with a 50% safety margin. They could handle twice the load they'd ever see. The shock absorbers were simple twin-tube designs with massive reservoirs, running at low pressure so they'd never blow seals. The chassis was a unibody, which should have been weak, but Volvo reinforced it in ways nobody else was doing. Extra cross members welded into the floor, box section, side rails instead of channels, gussets and braces in every stress point. The chassis weighed more than it needed to, but it was rigid enough to last decades. The electrical system was 6-volt, which seems primitive, but it was actually genius for reliability. Lower voltage meant less stress on connections, less corrosion, simpler circuits. The wiring was copper, not aluminum, with rubber insulation that was actually oil-resistant. The generator was a Bosch unit, built like a tank. Even the paint was special. Volvo used a phosphate wash before painting, creating a chemical bond between the steel and paint that resisted rust better than anything else available in the 50s. They applied multiple coats, wet sanding between each layer. The paint was baked at high temperature, creating a finish that was genuinely durable. The whole car was engineered on one principle. Every component would either last the life of the vehicle or be easily replaceable. There were no compromises for cost or performance, just simple, proven, overbuilt components assembled with obsessive attention to detail. The durability testing that changed everything. Volvo's testing regime was insane by 1950s standards. While American manufacturers were doing 10,000-mile tests, Volvo was running their prototypes for 100,000 miles. On purpose. They built a test track in Gothenburg that was designed to destroy cars. The track had sections of cobblestone that would shake fillings out of your teeth, sections of corrugated concrete that resonated at the exact frequency to break welds, water troughs to simulate floods, a salt spray chamber to accelerate rust, hills steep enough to overheat brakes. They even had a section where they'd freeze the car overnight, then start it cold and immediately run it at full throttle. The engineers would drive these test cars for 8-hour shifts, back to back, around the clock. They'd record every squeak, every rattle, every failure. Then they'd redesign the failed component and start again. They did this for years before the car went into production. But here's where it gets really interesting. Volvo started doing something no other manufacturer was doing. They'd buy back used PV444s from customers, high-mileage examples, and tear them apart bolt by bolt. They'd measure wear on every component, looking for patterns, They discovered the cylinder walls wore unevenly, so they changed the honing pattern. They found the clutch pressure plate was cracking, so they redesigned it with more fingers and less spring pressure. They noticed the door hinges were sagging, so they made them heavier. Every problem they found in the field, they fixed in production. By 1956, the PV444 being sold was about the 10th major iteration of the design. It looked the same, but underneath, it was massively improved. The engine block was stronger. The transmission gears were harder. The suspension mounts were reinforced, all based on real-world data from high-mileage cars. Then Volvo did something unprecedented. They offered a warranty. Not a 90-day warranty like most manufacturers, not even a 1-year warranty. They offered 5 years or 50,000 miles, whichever came first. In 1956, this was unheard of. It was financial suicide according to every other manufacturer. Except it wasn't. The warranty claims were minimal. Cars were coming in for service at 50,000 miles, with basically nothing wrong. Dealers were confused. They'd do an inspection, change the oil, send people home. No major repairs, no replacement parts, nothing. A dealer in Stockholm kept records of the first 100 PV444s he sold. By the time they hit 100,000 kilometers, which is about 62,000 miles, exactly 3 had needed major repairs. 1 clutch replacement, 1 generator rebuild, 1 rear axle seal. That's it. Everything else was just consumables: oil, filters, brake shoes. American dealers started importing them unofficially to see what the fuss was about. A dealer in California bought one in '56 and put it in his rental fleet as an experiment. By '59, it had 90,000 miles. The only repairs had been a water pump and brake shoes. He bought 10 more. Consumer Reports got hold of one in '57 and ran their standard test protocol. Then they kept it for another year because they couldn't break it. They finally gave up at 60,000 miles and wrote a review that basically said, "We don't understand how this car exists. Real-world proof. The stories that built the legend." The stories started coming in almost immediately. A taxi driver in Stockholm bought a PV444 in '55 and was still driving it in '65 with 400,000 kilometers on the clock. Original engine, original transmission. He'd replaced the clutch twice and the brakes constantly because taxi driving, but nothing else major. He finally sold it to another taxi driver who drove it for another 5 years. A rural mail carrier in northern Sweden took delivery of a PV444 in '56. His route was 200 kilometers a day on dirt roads, through snow 6 months of the year, temperatures down to -40. The car ran for 11 years without ever missing a day. When they finally retired it in '67, it had over 900,000 kilometers. The engine still ran, the body was rusted through, but the mechanicals were sound. In America, a guy in Alaska named Tom Wilson bought a PV444 in '58. He drove it from Anchorage to Fairbanks and back, year-round, for his job as a mining engineer. This is a drive that destroys normal cars in months. The PV444 lasted 7 years and over 200,000 miles before the body rusted out from the salt they used on the Alcon Highway. He pulled the engine and transmission and put them in his next Volvo. A college professor in California bought one in '56 and drove it every day to work, 30 miles each way. He was meticulous about maintenance, changing oil every 3,000 miles, keeping records of every fill-up. When the car passed 100,000 miles in '61, he wrote to Volvo to tell them. They asked him to keep going and keep records. He drove that car until 1974, 437,000 miles. He had the engine apart exactly once, at 200,000 miles, to replace the piston rings. Everything else was original. The transmission still shifted perfectly. The rear axle still didn't leak. The chassis had some rust but was structurally sound. When he finally donated it to a museum, it still ran. These weren't isolated cases. They were normal. Volvo started collecting stories from owners, publishing them in newsletters. A doctor who did house calls in rural Norway, 300,000 miles. A salesman in Denmark, 400,000 kilometers. A farm family in Wisconsin who bought one in '58 and passed it down through 3 generations. The used car market for PV444s was insane. A 5-year-old example with 100,000 miles would sell for 70% of new price, because everyone knew it had 300,000 miles left in it. People were buying them as investments. You could drive a PV444 for 10 years, sell it for half what you paid, and consider that a win. Insurance companies started offering discounts for PV444 owners because the cars were so reliable. Actuaries ran the numbers and found that PV444 owners filed fewer claims for mechanical breakdown than any other car on the road. It wasn't even close. The next most reliable car had 3 times the failure rate. Mechanics started to hate them, actually. There was no money in maintaining PV444s. Owners would bring them in for scheduled service. The mechanic would look for problems to fix, find nothing, change the oil, and send them home. One mechanic in Seattle reportedly told a PV444 owner, "Come back when something's actually wrong. I've got real broken cars to fix." The Swedish military bought hundreds of them as staff cars. They'd typically replace vehicles every 3 years and 50,000 miles. The PV444s were still running at 10 years and 200,000 miles with no signs of wear. They finally sold them as surplus, and those surplus military PV444s became legendary. Everyone wanted one because they'd been maintained perfectly and still had decades of life left. How Detroit and the competition reacted. Detroit's initial reaction was to ignore Volvo entirely. They were a tiny company selling maybe 10,000 cars a year in the US. Who cares? Let them have their little niche. American buyers wanted power, size, and features. Nobody wanted some Swedish penalty box. But then the warranty costs started adding up. GM's warranty expense in 1957 was running at 8% of sales. Ford was at 7%. Chrysler was at 9%. These companies were spending hundreds of millions of dollars fixing cars under warranty. And here was Volvo, with a 5-year warranty, spending almost nothing. GM sent engineers to Sweden in '58 to tour the Volvo factory. They expected to find some secret manufacturing process, some special Swedish metallurgy. What they found was obsessive attention to detail and components engineered for durability instead of cost. The GM engineers wrote a report basically saying, "They're just building cars the way we used to before we got smart about planned obsolescence." The report was buried. GM had no interest in building cars that lasted 30 years. Their entire business model depended on people buying new cars every 3 to 5 years. Building Volvo-level durability would destroy the used car market and kill new car sales. It was commercially suicide. Ford took a different approach. They tried to discredit the durability claims. They ran ads showing Fords that had gone 100,000 miles, implying their cars were just as durable, except everyone knew those were cherry-picked examples, while every PV444 could do it. The British car companies panicked. MG, Triumph, and Austin Healey were selling sporty cars to Americans who wanted something different. But those cars were maintenance nightmares. The PV444 wasn't sporty, but it was different, and it actually worked. British car sales started dropping as word spread about Volvo's reliability. Mercedes-Benz was the most concerned. They'd built their reputation on German engineering and durability. They charged premium prices, partly based on that reputation. But Volvo was matching their durability at half the price. Mercedes dealers started seeing customers cross-shopping PV444s against 180 sedans and choosing the Volvo. Mercedes responded by doing what they do best, engineering even more durability into their cars and raising prices to match. They positioned themselves as the luxury durable car, letting Volvo own the affordable, durable segment. It actually worked, creating 2 distinct markets. The Japanese were paying very close attention. Toyota and Nissan were just starting to export to America in the late 50s. They studied the PV444 obsessively. They tore them apart. They read every Volvo technical manual they could find. The Japanese approach to building durable, reliable cars owes a massive debt to what Volvo pioneered with the PV444. Some American dealers who sold PV444s reported getting visits from people claiming to be interested customers, but asking very technical questions about manufacturing processes and quality control. They were obviously competitor spies trying to figure out how Volvo was doing it. The automotive press didn't know what to make of it. Durability wasn't exciting. It didn't photograph well. You couldn't demonstrate it in a road test. But they started getting letters from readers asking about reliability, about long-term costs, about which cars would last, topics that had never come up before. Consumer Reports changed their testing methodology because of the PV444. They started doing long-term tests, tracking cars for 50,000 miles instead of 5,000. They started surveying owners about reliability. They created reliability ratings that would eventually become the foundation of their entire car testing program. The cultural impact and legacy. The PV444 did something no other car had done. It created the concept of the durable European import. Before the PV444, European cars were viewed as quirky, temperamental, and expensive to maintain. The PV444 proved you could have European character with Japanese-level reliability years before the Japanese achieved that reputation. It created Volvo's entire brand identity. Before the PV444, Volvo was an obscure Swedish manufacturer nobody had heard of. After the PV444, Volvo meant durability. When they introduced the Amazon in '56 and the P1861, people bought them sight unseen because Volvo meant the car would last forever. The PV444 influenced Volvo's later cars in obvious ways. The Amazon was basically a larger, more modern PV444. The 140 series in the 60s was the PV444's engineering philosophy, scaled up to a family sedan. The 240, which became legendary for million-mile durability, was a direct descendant of the PV444's obsessive overengineering. It changed how people thought about car ownership. Before the PV444, you bought a car, drove it until it broke, then bought another car. The PV444 introduced the idea that a car could be a long-term investment, that proper maintenance could give you decades of service, that maybe you didn't need to chase the newest model every few years. The environmental impact was profound, though nobody thought about it that way in the 50s. A car that lasts 30 years instead of 5 means 1/6 the manufacturing waste, 1/6 the resource consumption. The PV444 was the original sustainable car, decades before sustainability was a concept. It created a collector market that still exists today. PV444s, in good condition, sell for $20,000 to $30,000 now. Not because they're fast or beautiful, but because they represent something important in automotive history. The car that proved durability was possible. The modification scene was weird and wonderful. People would buy high-mileage PV444s for cheap, knowing the mechanicals were sound, and turn them into hot rods. The engine could be hopped up to over 100 horsepower, with period-correct modifications. The chassis could handle it because it was overbuilt from the factory, why it matters today. Here's what the 1956 Volvo PV444 proved. Durability isn't about technology, it's about priorities. Volvo built a car with 1930s technology that outlasted cars with much more advanced engineering because they prioritized longevity over everything else. Modern cars are more reliable than 1950s cars, absolutely, but they're not more durable. A modern car will run trouble-free for 100,000 miles, but then the electronics start failing, the turbos need replacement, the sensors die. The PV444 would run for 400,000 miles with basic maintenance and minimal repairs. The planned obsolescence that Detroit weaponized against the PV444 won in the marketplace but lost in history. Nobody remembers the '56 Chevy Bel Air for its reliability. They remember it for its style. The PV444 is remembered specifically because it lasted. The lesson about overengineering is critical. Volvo spent more money on components than they needed to, making the car more expensive to build. But that expense was invisible to customers and created legendary reliability that built brand loyalty for decades. They lost money on each car but made it back 10 times over in reputation. The current automotive industry is struggling with this same question. Electric vehicles will last longer than combustion cars mechanically, but the batteries don't. The electronics are complicated and fail. The software needs updates. We're building cars that will be obsolete in 10 years, not because they wear out, but because they can't be supported. What if someone built a modern car with PV444 philosophy? Simple, proven technology, overbuilt components, designed for a 30-year lifespan, no planned obsolescence. It would be more expensive initially, but cheaper over its lifetime. The environmental impact would be massive. The cultural impact would be revolutionary. The PV444 reminds us that sometimes the best solution isn't the newest or the most advanced. Sometimes it's the simplest, most reliable, most carefully executed idea that wins. Not in the sales charts, maybe, but in the long run of history. Today, with concerns about sustainability and resource consumption, the PV444's approach looks prophetic. Build it once, build it right, build it to last, then maintain it and drive it for decades. It's the opposite of our current throwaway culture, and maybe, just maybe, it's what we need to get back to. The 60 horsepower engine that everyone mocked, it's still running in cars 70 years later. The beam axles that seemed so primitive, still solid. The 3-speed transmission, still shifting smoothly. The 1956 Volvo PV444 wasn't the fastest car, or the most advanced, or the most beautiful, but it was the most durable passenger car ever built when it was new. And that achievement stands the test of time in a way that horsepower numbers and 0 to 60 times never could. Sometimes, showing up and refusing to die is the ultimate performance metric. The PV444 showed up in '56 and is still showing up today, still running, still proving that when you build something right, it lasts forever.